Solar energy. Solar energy is one of the cleanest and most abundant renewable energy sources available. It harnesses the power of the sun using technology such as solar panels. These panels contain photovoltaic cells that convert sunlight directly into electricity. The process is both silent and pollution-free, making it highly beneficial for the environment. The profound impact of solar energy lies in its potential to meet much of the world's energy needs without contributing to climate change. Sunlight is virtually limitless and can be accessed anywhere on Earth to some degree. This makes solar energy a key player in reducing our reliance on fossil fuels, which are finite and emit greenhouse gases when burned. Investments in solar technology have led to significant advancements, making it more efficient and cheaper than ever before. Solar panels can be installed on rooftops, in large outdoor fields, or even integrated into building materials. The flexibility and scalability of solar installations mean they can power anything from a single home to an entire city. Moreover, as solar energy does not require fuel and has minimal operating costs, it offers long-term savings and a stable energy supply, crucial for energy security in an increasingly uncertain global energy landscape. Wind energy. Wind energy is captured using turbines that convert the kinetic energy of wind into mechanical power, which can then be transformed into electricity. This process involves large blades mounted on a tower to capture the wind. As the wind blows, it pushes against the blades, causing them to turn. The blades are connected to a shaft, which spins a generator to produce electricity. The significance of wind energy is profound as it provides a sustainable alternative to fossil fuels. It is one of the fastest-growing energy sources in the world and is particularly beneficial in areas with strong, consistent winds. Wind farms can be established onshore or offshore. Offshore wind farms typically generate more energy due to the stronger and more consistent winds found at sea. One of the key insights into wind energy is its role in reducing air pollution and greenhouse gas emissions. Unlike conventional power plants, wind turbines produce no air pollutants or greenhouse gases. Moreover, wind energy is a domestic source of energy, which enhances national security by reducing dependence on imported fuels. However, wind energy also faces challenges such as variability in wind speed, which can affect power generation. Advances in technology and grid management are helping to mitigate these issues, making wind a reliable component of the future energy mix. This is crucial as societies aim to transition towards more sustainable and resilient energy systems.
Click subscribe to this channel to get more topics you love.
Hydroelectric energy. Hydroelectric energy is one of the oldest and most mature renewable energy technologies. It is produced by capturing the kinetic energy of flowing water. Dams are often built on large rivers, creating reservoirs. Water released from these reservoirs flows through turbines, spinning them to generate electricity. The profoundness of hydroelectric energy lies in its efficiency and reliability. It has the highest energy conversion efficiency among renewable resources, with modern hydro plants achieving more than 90% efficiency. It's also capable of adjusting the power output quickly to match demand, providing a stable and reliable energy supply, crucial for balancing the grid. Hydroelectric power not only contributes to energy security but also provides additional benefits such as water supply for agriculture, flood control, and recreational opportunities. However, it is not without environmental impacts. Large hydro projects can disrupt local ecosystems, affect water temperatures and flows, and displace communities. Despite these challenges, hydroelectric energy remains a key component of global energy strategies aimed at reducing carbon emissions and transitioning to sustainable energy futures. It exemplifies how traditional energy sources can adapt to modern energy demands and environmental considerations. Nuclear energy. Nuclear energy is generated through the process of nuclear fission. In a nuclear reactor, uranium atoms are split to release energy in the form of heat. This heat is used to produce steam, which drives turbines to generate electricity. This process is carried out under controlled conditions in a nuclear power plant. The significance of nuclear energy lies in its capacity to generate large amounts of continuous, reliable electricity without the emission of greenhouse gases during operation. It is one of the most concentrated forms of energy available. A small amount of nuclear fuel can produce a vast amount of energy compared to fossil fuels. This makes nuclear power a potent tool in the fight against climate change. However, nuclear energy comes with profound safety, political, and environmental challenges. The risks of nuclear accidents, as seen in Chernobyl and Fukushima, raise serious safety concerns. Additionally, the problem of nuclear waste, which remains radioactive and hazardous for thousands of years, poses significant environmental and health risks. Despite these issues, nuclear energy provides a critical bridge in transitioning away from fossil fuels. Advanced reactor designs and better waste management practices are being developed to enhance the safety and sustainability of nuclear power, making it an indispensable part of our energy future. Coal energy. Coal energy is produced by burning coal to generate electricity. Coal is a combustible black or brownish-black sedimentary rock composed mostly of carbon and hydrocarbons. It is the most abundant fossil fuel on Earth and has been used to produce energy since the Industrial Revolution. Coal power plants operate by burning coal to heat water in a boiler, creating steam. The steam is then used to spin a turbine, which drives a generator to produce electricity. The process is efficient in terms of energy output, but it has significant environmental and health impacts. The burning of coal is a major source of greenhouse gas emissions, which contribute to global warming and climate change. Additionally, coal combustion produces pollutants such as sulfur dioxide, nitrogen oxides, and particulate matter, which can cause severe air quality issues and health problems such as respiratory illnesses and heart disease. Despite these profound drawbacks, coal has historically been a favored energy source due to its abundance and low cost. However, the world is increasingly shifting towards cleaner energy sources. This transition is driven by the urgent need to address environmental concerns and the long-term economic benefits of renewable energy technologies. The decline of coal is not just an environmental imperative but also an economic strategy, as countries aim to reduce dependence on an energy source that is not only harmful to the planet but also subject to volatile prices. The future of energy is likely to see a continued decrease in coal use, replaced by a diverse mix of energy sources that prioritize sustainability, reliability, and affordability. Natural gas. Natural gas is a fossil fuel used primarily for heating and generating electricity. It consists mainly of methane, a highly combustible molecule made up of carbon and hydrogen. Unlike other fossil fuels, natural gas burns cleaner, releasing fewer byproducts harmful to the environment. This energy source is often praised for its efficiency and its role as a bridge fuel in the transition towards renewable energy. When burned, natural gas produces half as much carbon dioxide as coal and about 30% less than oil. It also emits lower levels of harmful pollutants such as sulfur dioxide and particulate matter. The extraction of natural gas through techniques like hydraulic fracturing, or fracking, has led to abundant supplies and lower prices, making it an attractive energy choice for many countries. However, the process of extracting and transporting natural gas can lead to methane leaks, which are significantly more potent than carbon dioxide in terms of greenhouse effect. Natural gas is pivotal in the current energy landscape because it can provide consistent energy output that renewables like solar and wind currently cannot ensure due to their intermittency. This makes natural gas essential for maintaining the stability of the electrical grid during transitions in weather and daily demand cycles. Despite its benefits, the reliance on natural gas poses challenges for long-term climate goals. It remains a fossil fuel with a substantial carbon footprint, and its infrastructure investments can delay the adoption of fully renewable energy systems. Thus, while natural gas plays a significant role now, its future in the energy mix must be carefully managed to align with global sustainability targets. Biomass energy. Biomass energy is produced from organic materials such as plant leftovers, wood, and even animal waste. These materials are natural and renewable, making biomass a significant player in the renewable energy sector. When these organic materials decompose or are burned, they release the stored chemical energy as heat, which can then be used to generate electricity or produce heat directly. The real beauty of biomass energy is its ability to transform waste products into valuable energy, reducing landfill use and cutting down methane emissions from decomposing waste in open air. This cycle of growing, using, and regenerating is aligned with the natural carbon cycle, making biomass a potentially carbon-neutral source of energy. Plants absorb carbon dioxide as they grow, which theoretically offsets the CO2 released during biomass combustion. However, the sustainability of biomass energy depends profoundly on how the biomass sources are managed. Sustainable practices are crucial to ensure that biomass use does not lead to deforestation or soil degradation. Moreover, while biomass is renewable, it is not completely without environmental impact, particularly concerning air quality due to emissions from burning. Biomass energy represents a critical step towards a more circular economy, where waste becomes a resource, thus promoting environmental sustainability and energy security. It showcases the interconnectedness of ecological cycles and energy production, highlighting the importance of responsible resource management. Geothermal energy. Geothermal energy taps into the heat stored beneath the Earth's surface to generate electricity and provide heating. This energy source is not only abundant but also constant, unlike solar or wind energy, which depend on weather conditions. The core of the Earth is incredibly hot, and this heat naturally flows outward, warming the surrounding geological layers, including water reservoirs known as geothermal reservoirs. The process involves drilling wells into these reservoirs to bring hot water and steam to the surface. This steam then drives turbines that generate electricity. For heating purposes, the hot water can be directly used to heat buildings and greenhouses. What makes geothermal energy profoundly impactful is its minimal environmental footprint and exceptional reliability. It produces a fraction of the emissions that fossil fuels do, helping to mitigate climate change, and its power output is both stable and predictable, providing an essential base load energy supply for the power grid. Moreover, geothermal energy exploitation helps local economies by creating jobs in plant construction and operation while using land more efficiently compared to other renewable resources. However, it is geographically limited to regions with accessible geothermal resources, typically along tectonic plate boundaries. Geothermal energy exemplifies how deep Earth systems can be harnessed, offering a glimpse into the sustainable use of our planet's inherent thermal energy. Petroleum, oil, energy. Petroleum, or oil energy, is derived from crude oil, a complex mixture of hydrocarbons found deep beneath the Earth's surface. Once extracted, crude oil is refined into various fuels, including gasoline, diesel, and jet fuel, which power vehicles, aircraft, and ships, as well as heating oils and the production of electricity. The extraction and refining of petroleum have powered global industries and transportation for over a century, making it a cornerstone of modern economies. However, its profound impact on society comes with significant environmental and geopolitical challenges. The burning of petroleum fuels is a major source of carbon dioxide, a leading greenhouse gas. Additionally, oil spills and the ecological disruption caused by drilling have far-reaching environmental impacts. Despite these issues, petroleum remains a critical global resource. Its high energy density, ease of transport and storage, and versatility make it difficult to replace completely in the near term. The global dependency on oil has also intertwined it deeply with geopolitical strategies, affecting everything from national security to economic stability. The ongoing challenge is to manage this dependency while transitioning to cleaner energy sources, reflecting the complex balance between meeting immediate energy needs and ensuring long-term sustainability. Tidal energy. Tidal energy is a form of hydropower that converts the energy obtained from tides into useful forms of power, mainly electricity. It is harnessed by constructing turbines in tidal streams or by placing barrages across estuaries which capture potential energy from tidal waters. As tides are caused by the gravitational forces of the Moon and Sun combined with the Earth's rotation, this type of energy is more predictable than solar and wind power. The profound insight of tidal energy lies in its potential for reliability and sustainability. Tides are inexhaustible and predictable, making tidal energy a reliable source of renewable energy. The technology to capture tidal energy ranges from underwater turbines, which work similarly to wind turbines but are driven by moving water, to tidal barrages that utilize the difference in water levels between high and low tides. However, the development of tidal energy is not without challenges. The environmental impacts, including potential effects on marine ecosystems and sediment transport, need careful consideration. Additionally, the high costs and technological challenges associated with developing robust equipment capable of withstanding harsh marine environments are significant. Tidal energy exemplifies how the natural rhythms of our planet can be aligned with our energy needs, offering a vision of a sustainable future that harnesses the power of our oceans in harmony with ecological preservation. Its development speaks to a broader narrative of finding balance between leveraging natural resources and maintaining the health of our planet's ecosystems.